Welcome to LearnQuest Academy. Today we are going to be learning how to name organic compounds. Before I forget, make sure you follow LearnQuest Academy on WhatsApp. You'll gain a lot from it. I wish you success in your exams. Now, to name this organic compound, know that this is a skeletal structure. So this organic compound right here is question 1. Is drawn in a skeletal structure. And in this skeletal structure, it is what they mean is there's a carbon atom here, another here, another carbon atom here, another here, another here, and another here. So there are 6 carbon atoms in total at all these junctions. And this is a substituent, and this is a substituent. Substituent are simply elements or compounds that are added to the parent chain. After drawing the compound in common structure, we are going to be using the PSLA rule. I'll call the first step step P. P stands for parent. So the first step is to identify the parent chain. From here, this is the parent chain. Why did I call this the parent chain? Because it is the longest continuous carbon atom. So there are 3 conditions that the parent chain must satisfy. First of all, it must be the longest continuous carbon atom, or carbon chain rather, only the longest continuous carbon chain. Then it must have all the substituents, and it must contain the functional group of the organic compound. In what you can see above, this is an alkane. So an alkane functional group is just a single bond, and this is a single bond. So there is no special functional group for alkanes. After identifying the parent chain, which is this, we identify the substituents. That's what S stands for. We identify the substituents, which are this and this. The next step is step L, which stands for list number. So you are going to be naming the parent chain. You are going to be naming all the carbon atoms there, such that the substituents will have the list number that are attached to them. What do I mean by that? When we look at this organic compound, let us name it backwards. This is 1, 2, 3, 4, 5, and 6. So naming this organic compound backward, this chlorine, we have 1 chloro, and this one we have 4 propyl. But if I should name it forward, so let's erase this. If I should name it forward, this would be 1, this would be 2, this would be 3, this would be 4, this would be 5, and this would be 6. If I should name it forward, you'll see that this one we have 3 propyl. I'm talking about this substituent right here. So you have 3 propyl, while this we have 6 chloro. 6 chloro. So from that we can deduce that instead of having 3 propyl and 6 chloro, if we do it as 1 chloro and 4 propyl, the substituents we have the least possible number. As you can see here, we numbered it forward and backward. Then from numbering forward and backward, we discover that this we actually give the substituents the least possible number, and therefore we are going for 1 chloro and 4 propyl. The last step is step A, which stands for alphabetical order. So when you are naming organic compounds, you make sure that the substituents follow alphabetical order. For example, C in this organic compound, C comes before P, and C is 1-chloro, P is 4-propyl. So that means that in the hyperchlem, you must have it 1-chloro followed by 4-propyl. Then the parent chain is hexane. As you can see here, we have 6 carbon atoms in the parent chain. So, and 6 stands for X. So that would be hexane. So that's why the name of the organic compound is 1-chloro, 4-propyl hexane. You separate letters from numbers by hyphen. This is the hyphen here. While if you have two numbers beside each other, you separate them with comma. So assuming it was 1,1, or 1,1 dichloro 4-propyl hexane. You can see that this number are separated with commas, while the numbers and letters are separated with hyphen. Let's move on to the next organic compound. We have to name this organic compound. This one is drawn in normal structure. This is a substituent, and this is a substituent. Some of you might be thinking that this is a substituent, but we'll come to that. This is actually not a substituent. Yeah, actually not a substituent. I intentionally said it was a substituent before, because I know some of you might think that, oh, because it's written this way, that means that it's a substituent. So let me explain. The first step, just like I said before, PSLA. That's the PSLA rule, is to identify a parent chain. As you can see, this carbon atom here is attached to the terminal carbon atom. That's the last carbon atom. That means that it is also part of the parent chain. I remember what I said before, up right here. The parent chain must have what? 3 properties. The functional group of the organic compound, must have all the substituents, and it must be the longest continuous carbon chain with all the above properties. From the next question, we can see that it is an alkene. And alkenes have the functional group of double bond. So the parent chain too, we have the functional group, which is the double bond. So this will be the parent chain right here. And let us count the number of carbon atoms that are there. It is 1, 2, 3, 4, 5, 6, and 7. So there are 7 carbon atoms there. So this is heptene, 7 carbon atoms. After that, don't forget, that is step P, the parent chain. The next step is step S, which is the substituent. You identify the substituent, which is only I. That's iodine. After identifying the substituent, you make sure that the substituent has the least possible number attached to them. So we name forward, we number it backward first. After numbering it backward, we discover that I has 5 iodo. Now let's number it forward. We discover that it has, if we number it forward, you see that it have 1, 2, 3, 4, and like that. So it will have 3 iodo. And there's an exception. Now, you remember that before I said it must have the least possible number, but we already have a double bond here. So you are going to count from the side in which the double bond give you the least possible number. So if we number forward, we'll discover that the double bond will be on carbon atom 5. But if we number backward, we'll discover that it will be on carbon atom 2. So we are going to go with numbering backward. And when we number backward, iodo is on 5. So since the double bond must have the least possible number, we are giving it priority. Whenever you have a functional group, you give the functional group a priority in naming the organic compound. So we are going to have 5 iodo. Now the next step is step A. after PS, sorry, step L, that's the least possible number. We've done that. Then step A, which is alphabetical order. Now this rule does not apply here because there's only one substituent, so it's going to be, the organic compound is going to be 5-iodo hept 2-ene. And a key rule to take note of in this video is the PSLA rule, where P stands for parent, S for substituent, L for list of possible number, and A for alphabetical order. A way you can always use to remember this is parent start lesson always. You know the parent always starts, so parent start, then lessons always. That's a simple acronym to always use to remember. Now I'm going to be explaining the various forms in which the structure of an organic compound can be drawn. You can have a common structure, which is for our second question. So it's what was drawn for our second question here, where we had this. So it's a common structure. Then you can have an organic compound drawn in a zigzag structure, where the substituents are going to be bent. You can see that, sorry, I mean the parent chain is actually bent. You can see that here, even though it's a long continuous carbon chain, we still made the parent chain, we still brought one CH3 here, one CH3 here. This is the same as this, just that now it's kind of zigzag like this. We also have the staggered structure, which is this. It's like you're condensing everything, where we have CH3, CH2, CH2, just like that. Or you can have it like this, where you don't show these lines. Or we also have the condensed structure. The major difference between the staggered and condensed structure is, look at this part. You can see that they are separate, but in condensed structure they will be together. It's very, very condensed. After that, we have the skeletal structure, which I explained before. There's a carbon atom here, a carbon atom here, a carbon atom here. If nothing is given in this place, that means there is a carbon atom. There is bromine there, carbon atom, and carbon atom. Note what I did here. I intentionally use one organic compound for everything. So for the common structure, this is how the compound is. These are the compound they look like. You can try to name this compound. As you can see, definitely this compound is 3 bromo, 3 methyl, 1 2 3 4 5 6 hexane. That's the name of the organic compound. Then you can see that in zigzag structure, this is how it looks like. In stagger structure, this is how it looks like. And in condensed structure and skeletal structure, this is how the organic compound looks like. So whenever you see this one, Position loves to ask this a lot. This is an exercise that you can try on your own. This is a functional group. I put a hint there. This is a functional group. This is the functional group. So you can try to name these organic compounds on your own to better understand the PSLA rule. And these are the answers. You can look at them together. So thank you so much for watching. Don't forget to like and subscribe, and also check the video description for more information about this video. See you later.